Good day, everyone. My name is Harren, and I am representing Group Expert Group 4 to present about correction of SPT N value, also known as N60. So, the standard penetration test or SPT is used in geotechnical engineering to measure soil resistance. The SPT N value represents the number of blows required to drive a sampler into the soil for 300 mm after an initial seeding drive. However, the raw N value obtained in the field is not always accurate because it is affected by different field conditions. So we apply corrections to make the value more reliable. There are two main types of corrections: overburden corrections, which accounts for confining pressure, and dilatancy correction, which applies mainly to fine sand and silty sand below the water table when N is greater than 15. It is important to note that overburden correction is applied first, followed by dilatancy correction if needed. So this is the overall process for correcting the SPT N value. First, we start with the field N value. Then we apply corrections related to field procedure to obtain N60. Next, we consider the soil type and apply overburden pressure correction to get N160. If the soil is fine sand or silt below the water table and the value is greater than 50, we apply dilatancy correction. Finally, we obtain the corrected value, which is used for design and analysis. Now I am going to explain the formula. To calculate N60, we use this formula. Basically, N60 equals N multiplied by several correction factors. These include energy correction factor CE, borehole diameter factor CB, road length factor CR, sampler correction factor CS. Each factor adjusts the N value based on field conditions. For example, the energy factor depends on the hammer type. Borehole factor depends on hole diameter. Road length affect energy loss. Sampler type also changes the result. All these corrections help standardize the N value to a consistent energy level of 60%. So this is the sample calculation. So the recorded below counts are 9, 16 and 19. We ignore the first value and add the next two. So N equals to 16 plus 19, which is 35. Next, we apply correction factor. CE is 70% and value for CB, CS and CR is 1.05, 1.00 and 0.95. By substituting into the formula, we get N60 equals to 41. This shows how the corrected value is higher than the original field value, giving a more accurate representation of soil strength. In conclusion, correcting the SPT-N value to N60 is very important in geotechnical engineering. Raw field values can be misleading due to varying test conditions. By applying proper corrections, we obtain standardized and reliable results. This leads to better soil evaluation, safer foundation design, more accurate engineering decision. Therefore, N60 is essential for ensuring safety and reliability in construction projects. Thank you.